Composition is not something you will use in your everyday life, but you will use it just about every day of your calculus career. Raise your hand if you anticipate you might take calculus someday. That's 2/3 of the class. So you guys will be using this stuff a lot. F of g of x. That's what that means. F of g of x. That's what it says. And what that means is f of g of x. That's another way of writing it, okay? So these are synonymous with one another. This and this are the same, okay? No, that is not the same. So what that means is you take x and you start by plugging it into g. You have this g function. When you plug x into g, you get an output. You get an output of g of x. Then you take that g of x value and you plug it into f. And your output would be f of whatever your input was. What was my input to the function? G of x. So it says, given f of x is 2x minus 3, g of x is x squared plus 2x, find the following. F of g of 0. So what I do first is I find g of 0. So this is equal to f of, I take 0 and I plug it in for g. F of 0 squared plus 2 times 0. What is that? 0. So then you take 0 and plug it in for f, which is 2 times 0 minus 3. It's okay. Jack, we celebrate people who give answers. It's easy to sit back and never say an answer. It takes somebody who is confident to speak forth an answer, right? No, you didn't blow it up, right? Right? Squirrel. All right. G of f of 0, okay? So, now look, I switched them, okay? I did f of g of 0, now I do g of f of 0. We call that commutativity. For example, is addition commutative? Can you switch the numbers and have it be the same in addition? Is subtraction? Is multiplication? Is division? No. Question is, do functions and composition match with commutativity? If you check here, it does not work out. You end up doing g of f of 0. So that's g of, if you plug 0 in for f, that's 2 times 0 minus 3, which gives you g of negative 3, which is? So that would be 9 minus 6 is 3. So over there we got negative 3. Over here we got positive 3. It's not always going to be the opposite value. It just happens to be that in this case. C. That's the same type of notation. I will write it out and then I'll erase it. When you see f of g of negative 2, that means f of g of negative 2. If you have to write it out every time like that, then so be it. But I will not. I will say that is going, yes. Because then you take negative 3 and you plug it in for this. Negative 3 squared is 9 plus negative 6 is 3. That make sense? F of g of negative 2. I take the negative 2 and I plug it in for g. What is g of negative 2? 0. So then you take f of 0, which happens to be negative 3. For D, I'm going to do g of f of negative 2. Do I plug negative 2 in for f or negative 2 in for g? In for f. What is f of negative 2? Negative 7. So g, then I take negative 7, I plug it in for g, and g of negative 7 is? Negative 7 squared is 49, minus 14 is 35. Question? Yes. Okay. So negative 2 squared is 4 plus 2 times negative 2 is negative 4, and you get 0. Right? You guys go ahead and you try E and F on your own. E and F on your own. Go ahead, try those two. Does anybody have a question on E or F? I came around, most people were getting it. For this one? So G of 1, so that would be G of, and then you plug 1 in for G. So 1 squared plus 2 times 1. Okay, Mercedes, you got it now? All right. Shh, folks, 2 more examples, then I'll let you work. I got to print something off, okay? F of G of X. What that means is I have F of X is equal to 2X minus 3, and I have G of X is equal to X squared plus 2X. So if I want to do F of G of X, I'm going to write a composition function using both of those together, okay? So that means I take G of X and I plug it in for X. A lot of people mistake this and they take 2x minus 3 times x squared plus 2x. You don't do that. You take f of g of x means we take 2 and instead of an x we place the function g of x. X squared plus 2x minus 3. So wherever there was an x, I place the function g of x. And I get 2x squared plus 4x minus 3. That is the correct answer. So h is the opposite, would be like positive or negative. I guess we switch the order. We switch the order for h. And so what we will do now is we're going to take this f, and where do we plug it in? For which spot? For both of them, don't we? Wherever there's an x, you have to place that function. So therefore, we get g of f of x is equal to 2x minus 3, that quantity squared, plus 2 times 2x minus 3. Okay? Help me out here. What's 2x minus 3 quantity squared? Thank you. So now we combine like terms. 4x squared minus 8x plus 3. That is f of g of x. You go ahead, do I and j on your own while I run a copy. Okay, this is very good. Who wrote up j? Who wrote j? Oh, you, okay. Try that again. I don't believe that. How's that? Okay. You did very good. Thank you. Just we'll clean up the X's a little bit, make it look beautiful. When I was your age, my handwriting did not look like it does now. Very similarly, no, but hey, here's why my handwriting improved. Number one, I was a teacher and people had to understand my handwriting, otherwise I wasn't doing my job. Number two, my professors in college, if they couldn't read it, they just went right by it. That happened to me once, and I would never let it happen again. So, I don't know. Oh, yes, Tyler, question, which one? Which one would you like to see, I or J? J? Folks. Okay, so the question is, how do we come up with J? It says G of G of X. So G of X is my input, and I'm going to plug that in for these X's. No. Folks. Too loud. X squared plus 2x. When we square that, we get x to the fourth. And then when you FOIL this out, you have x squared times 2x, which is 2x to the third. And then you have 2x times x squared, which is another 2x to the third. And that gives you 4x to the third. 2x quantity squared is 4x squared. 2 times x squared is 2x squared. And plus 4x. So 4x squared and 2x squared makes 6x squared. Yep. Okay, please copy the shape down. Well, notes are always optional. I mean, I don't give you credit for this. It is all up to your, what you want to have as you kind of work through your homework. So if it's too much work to copy it down, then just leave it blank and follow along. But if you'd like to have it for reference, then unfortunately, Microsoft Word does not have that great of options for inserting lines. They're a little bit picky about which pixels they end on. And so I always have you guys just write it in. Because I always forget to write it in when I make my copies. And I look forward to this one time during the year where I just sit for 80 seconds while you guys write. It's an arrow. Got erased from all the writing I was doing. Going home. Gonna play Jenga with my kids. Making homemade pizza for supper. Watching Andy Griffith, put them to bed. And then, because I graded all my papers last night, I'm gonna watch Lord of the Rings. Pepperoni, Canadian bacon. What? Yeah, but that takes I do if I go to Papa Murphy's, I get 5 meat stuffed crust pizza. That's what I get. Well, you get hamburger, you get sausage, you get I eat 5 of them. Yeah, moron, stupid. So what we want to do is we want to perform graphical addition, subtraction, multiplication, division, and then composition. So it says f plus g of 2. What that means is I take f of 2 and I add it to g of 2. I won't write that out each time because you need to start to just remember that's what it is. So what is f of 2? F is the blue function. Three plus what's g of 2? Negative 3. 3 plus negative 3? 0. G minus f of 0. So I identify g of 0, which is 4 minus f of 0. 1. What's 4 minus 1? F times g of 0, or of negative 1, excuse me. And part of the reason why I really like these problems is it expects that you understand the notation, and it doesn't give you any function rules like x squared plus 2x. That stuff you guys are so used to. This requires a conceptual understanding, a graphical approach. So f times g of negative 1. What's f of negative 1? F of negative 1 is 1 times, what's g of negative 1? 4. 1 times 4 is 4. Now I do f divided by g of 0. What's f of 0? 1. What is g of 0? 4. 1 divided by 4 is a 4. And now I have f of g of 1. What do I do? What do I do? Plug 1 into g. When you plug 1 into g, what do you get? You get positive 4 because g of 1 is not negative 2. It is positive 4. So now this becomes f of 4. What is f of 4? F of 4 is 3. And then g of f of negative 2. What do I do first? Plug in negative 2 for f. You plug in negative 2 for f, you get 1. Then plug in 1 for g, and you get 4. So on your test, okay, what I'm going to ask you guys to do is to do exactly this. I'm also going to ask you to do one more piece, and that's what you're going to learn tomorrow, which is you're going to do f inverse of 3. That does not mean f to the negative 1 power. That's a different operation that you learn tomorrow. So we're learning 2 new operations. Let's finish off by doing the final 2 problems of our notes for this section, and then we only have 2-9 left. Again, you're going to be ready to test on Tuesday. If I can get done with this, I can actually run your copies of your study guides. You can probably have them by the end of today. So find the composition of the following functions and identify their domain. We want to list f composite g. That means I take g of x, which is 3 minus x, and what do I do with it? I plug it into x. And I get 2 over 3 minus x. X can't equal 3, very good. But look at the beginning, folks. Your assignment yesterday, when we identified the domain for sums of functions and difference and product and quotient, what we did is we looked at the domain of the first function and we looked at the domain of the second function and we looked at their overlap. That is not the case anymore. What is the domain of 2 over x? X can't be 0. What is the domain of 3 minus x? All real numbers. So notice, domain, x can't be 0, and all real numbers. But look at this. What's the domain here? X can't be 3. So you can't simply look at the previous functions and identify the domain. You must look at the result and consider that. Okay? If you want to write it like that, or if you want to write negative infinity to positive 3, union with 3 to infinity. Awesome. Great. G of f, I will take what f is, 2x minus 6, and I'll plug it right in there. And what we get is the square root of the quantity 2x minus 6 minus 2. Can I simplify that? 2x minus 8. How do I identify the domain of a square root? I must make that greater than or equal to 0 because you can't take the square root of a negative. Do I have to draw a graph or can I just solve it? And just solve it because it's linear. It's the first degree. So I have 2x greater than or equal to 8 divided by 2. X greater than or equal to positive 4. You can leave it like that or you can write it like this. Either way is correct. Your assignment. That's not very nice. .8, page 225. Hey, 225, perfect square. That's it. Some of those problems go very quick because you're simply doing f of or g of. Emily has the first question. I'm coming over to help her. If you want a study guide, stick around after class for a while.